This is where China tried to build a road across the ocean Crimea and then sent part of it underwater. Before this link opened, this trip could take around 2 hours. Now, it can be done in about 30 minutes. The problem was not just distance. It was mud, typhoons, salt water, ship traffic, and a seabed that refused to behave.
Look closely at this junction near the tower.
The stress indicators are peaking here.
Yes, the thermal expansion data suggests.
The final answer was a hybrid. Bridges where ships could pass, islands where the road could descend, and an immersed tunnel beneath the busiest waterway.
The pressure is stabilizing at 2,000 psi.
Acknowledged. We are clear to continue the drive.
To create the island, engineers used huge steel cylinders, then filled them and locked them into the seabed like the bones of a man-made coastline. This island was not built for tourists. It was built as a transition machine, wool, turning a bridge into a tunnel.
The tunnel features multiple layers. The road deck above the utility and emergency conduits below.
That tower is not decoration. It helps the underwater tunnel breathe.
The laser scan confirms the alignment is within tolerance.
What about the pressure readings on the seal?
Holding steady. Looks good.
Each standard tube was like a floating building, roughly 165 meters long and weighing around 80,000 tons.
Bring the vibrator up slowly now. Check the levels on the far side, make sure it's smooth.
This segment shows a slight deviation here. The laser confirms it.
Yes, the scan data aligns with the previous batch readings.
Before it ever touched the sea, every tube had to become watertight, strong, and perfectly aligned.
Tug 1, increase power to 50%. We have maximum strain on lines 3 and 4.
Roger, Captain. Distance to pier, holding steady. Keep coming left.
right, hold it steady there. Coming down slowly. Keep monitoring the tension.
The journey to the installation site could stretch for dozens of kilometers, and the ocean gave them only narrow weather windows.
All vessels in the vicinity of the corridor, this is Marine Control. Maintain present position until the main structure has passed marker 046.
Over.
Barge 2, you are clear to proceed. Tug 1, hold position at waypoint Charlie until further notice.
Get clear of the girders. Move to shelter now. The wind is critical.
Out here, precision was not enough. They also had to beat tides, currents, and sudden weather. The tube could not simply be dropped on mud. First, the seabed had to be cut, treated, and leveled like an underwater runway. The tube had to sink slowly, badan, not as a falling object, but as a controlled piece of the highway.
All right, stabilize the camera on joint alignment. How does the gasket contact look?
It looks good from here. Minimal intrusion.
The new tunnel segment slowly settles onto the prepared foundation bed.
When two sections met underwater, the smallest error could become a leak, a delay, or a disaster.
The laser scan confirms the seal integrity right here.
Yes, the data looks good. No anomalies detected.
The pressure is holding steady at 500 bar.
Confirmed. The seal integrity looks good on the thermal scan.
One segment became 2, then 10, then 32 and cow, until the undersea highway finally stretched beneath the channel.
The overlap is exactly 200 millimeters right here.
Yeah, confirmed. Everything is within tolerance.
Keep the machine steady. We need more asphalt over here. Watch the edge, watch the edge.
A tunnel is not finished when the concrete is closed. It still needs power, lights, cameras, fire protection, drainage, and air. For drivers, it feels simple, Kuk, a few minutes underground. But above them is one of the busiest bodies of water in southern China.
Monitor the pressure on the distribution nozzle. It's fluctuating.
Copy. Adjusting the flow rate now.
The towers had to rise in a marine environment where wind, salt, and typhoons attack every exposed surface.
Taking up the slack on this side. Easy, easy. Bring it slightly starboard. Watch the waves.
Bring it down 20 centimeters. Easy now.
Hold position, checking alignment on the west side.
Copy that. Holding steady.
The bridge deck sits high enough for large ships to pass underneath, while the road stays strong against offshore winds.
.42 millimeters, still within tolerance. All right, let's move on to the corrosion check on the west side.
This was not one bridge. It was a chain of systems, each part solving a different problem.
The barriers look solid, and the light alignment is perfect. We are ready for opening.
Before the first public vehicles arrived, every lane, camera, fan, light, and emergency system had to be tested together. What used to feel like two separate shores now feels like one connected urban region.
Wow, look at that island!
It's so big. Are we driving on it now?
Almost, sweetie.
This is the moment the road seems to vanish into the ocean. For the driver, the transition is effortless. For engineers, it took 7 years of coordination across sea, steel, concrete, and mud.
Easy now, lower the caisson. Watch the tide, bring it down slow.
Every stage depended on the stage before it. One mistake in the seabed could affect the tunnel. One delay at sea could affect the entire route.
Reading stable at 5.2 amps.
Confirmed. Logging it now.
A tunnel under the sea must be designed not only to carry traffic, but to survive emergencies. Building it was only the first challenge. Keeping it safe in a typhoon-prone sea is the challenge that never ends. This project is not just a road. It changes how people, goods, and businesses move around the Greater Bay Area. From above, it looks like a simple line across water. From inside the story, it is a bridge, an island, a tunnel, and a battle with the sea. The impossible part was not one machine or one bridge. It was making thousands of moving parts work as one. The Shenzhen and Zhongshan Link proves that sometimes the shortest road between two cities goes over the sea, racked, and under it.
A monumental achievement connects the vibrant